Hello and welcome back. Uh, in this video, we'll see one of the example when you start a data scientist as a profile or a data scientist project. In the beginning, you should start with a small data set, and this is the one of the data set I have started. Means when I started my journey in data scientist. So this is a cancer rate before and after in Chernobyl. तो अभी आपको इसका स्टोरी पता नहीं होगा तो आई जस्ट गिव यू अ सिंपल 5 लाइन का जो एक थोड़ा सा ब्रीफ देता हूँ। एक एक्सप्लोजन हुआ था इन शर्नोबिल न्यूक्लियर पावर प्लांट में इन 1986। तो उससे पहले कुछ कैंसर के पेशेंट की जो रेट था या केसेस थे दे आर नॉमिनल, नॉट नॉमिनल बट वहाँ पे कम केसेस थे। एंड आफ्टर दैट रेडियो एक्टिव एक्टिव क्लाउड जब वहाँ पे एक्सप्लोजन हुआ इन सुएत यूनियन, तो उस टेरिटरी में आता था बेलारूस, यूक्रेन एंड रशिया। तो ये फेडरेशन के सुएत यूनियन में हुआ था ये जो पावर प्लांट एक्सप्लोजन। एंड अराउंड 8.4 मिलियन पीपल इन द थ्री कंट्री आर अफेक्टेड बिकॉज ऑफ दैट एक्सप्लोजन। तो उसके बाद जो कैंसर का जो केसेस थे इट स्टार्टेड इंक्रीजिंग वेरी रैपिडली एंड उनमें बहुत सारे टाइप के कैंसर्स लोगों को होना स्टार्ट हुआ बिकॉज ऑफ दैट एक्सप्लोजन। सो दिस डेटा सेट इट रिलेटेड टू दैट इंसिडेंट एंड ये आपको कैगल पे भी मिल जाएगा। सो यू कैन गो and download that data set and perform EDA. I'm not going to apply here algorithm because it is a hundred rows of data set. It is specifically for EDA. When you and when you do the exploratory data analysis, you understand the data very नियरली। मीन्स आप उस डेटा को इतना नियरली एनालाइज करते हो ना, तो आपको पता चल जाता है कि एग्जैक्टली उस डेटा सेट में क्या क्या है। सो विल स्टार्ट विथ इंपोर्टिंग द लाइब्रेरीज लाइक numpy, pandas, matplotlib and seaborn are these primary library. Whenever you start any project you should have these four library in your a project. Okay, after doing that I'll just run this because I have already run uh, and I read my dataset. You have to download that dataset from Kaggle, store it on your C drive or whenever you store it. Your as a I'll suggest create one folder called data scientist or a data science and create a project. And under a project you can have a project one, and then you have your dataset and your file that IP IPYNB file that is related to your coding file. You store it over there. You can create a text file or requirement file. Even you can create all the file in that folder only. So it is very easy to read those file. And whenever you have any problem related to that project, you can just go there and uh, आप उस फाइल को रीड कर सकते हो, उस पे कुछ काम करना है तो काम कर सकते हो। सो आई हैव जस्ट रीड माय फाइल और डेटा सेट मैंने रीड कर लिया बिकॉज आई हैव गिवन द डेटा सेट नेम एज अ डेटा सेट CSV। सो if you want to give a different data set name, you just have to rename that। And I use the pandas library, and in pandas I have uh, read.csv. This is for reading a CSV file. If I want to read the text file, I'll just use the text file Excel file. There are different notation. You can just go on panda.pandas, or you can just click here. You will understand what type of functionality or what parameter you should pass on this read.csv. Okay, and okay, then after that I look for my dataset shape. So I have number of row are like 84 rows. It is a very small data set and I have only 5 column. From that you can see here data frame dot df dot head. When I use the head, I'll get a first 5 rows from my data set. You can see here I have from started with 0 ended with 4. I have 5 rows and 4 columns, 5 columns. So my first column name is year, you can see, and I have the data which is from year 1985 and 86 only, not before that and after that, only 85 and 86. We are analyzing the data and the cases in 85 are less and 86 are more as per the data set, and we are going to analyze. And we'll go, if you have a client, you have to perform the EDA, and after that you have to show the insight from that data. So what we are doing, we are analyzing that data, and after that we are giving a conclusion, so people will understand what we have done over the coding and over that data set. Okay, so we have like called six as a woman and male and female usually have, but here woman and men we have. Then we have a location. This location, if you go and google it out, it is, I have just googled one of them, Gomel. It is come under the region of Be- Belarus. Belarus. It is one of the region Belarusian. It is before that I think Russia and Belarus के under आता है. So that's the thing. And yeah, सो ये यूक्रेन, बेलारूस और रशिया, इन तीनों सोवियत यूनियन पे अफेक्ट किया था, दैट्स व्हाई. सो ये जो, इफ यू गो ऑन डेटा सेट एंड इफ यू लुक एट a data set, you'll see we have like, if I just put it here, df of, I'll put a location over here, and I'll just write counts. Maybe I'll get it. Let's see. Okay, total count, number of rows. I need to put it value counts, and I'll get all the values. Like you can see here, Gomel. Then we have Mogi lives. I'll just go here and I'll check that also. Okay. Before that, I'll just have to. So this is come under again the city of Belarus, and I think Belarus is a and come under Russia. I don't know exactly, but ये city के name है जो they are in Soviet Union. Okay, uh, Gomel, Moji, Lev, and Belarus. So सब जगह यू कैन सी 28 28 एंड 28, तीनों जगह पे 28%, मतलब इक्वली इक्वल नंबर ऑफ पेशेंट्स है वहाँ पे. एंड देन वी हैव अ कैंसर टाइप. इफ यू आस्क व्हाट टाइप ऑफ कैंसर, लेट्स टेक दैट, and I'll just provide here. I'll get a, so you can see all of them. 12% of cancer are related to skin, then thyroid, lungs, pancreas, colon, then rectum, then kidney. You can search all this column and rectum. I don't know. You have to search it on Google. You can get a good idea. Then we have a cases, number of cases, or this is related. If you go on Kaggle, you'll get it from 100 of patients, how many cases are there. Like 17.3% of cases happen out of 100 patients. Okay, so just okay. After that, what we have like df.info, and I'll get it like year 6 location, and I'll get my all the column. You can see here there is no non null value, and we have like int value. First column is int, and then other column are object column. Object means it is a string type, and then we have a float type. You can see here, this is the float value and this is the string value. That's why it is called as an object. I know I'm explaining in very deep or very in whenever a person is in an early stage or is just started the data science journey, he should know. And those person who are in the mid, they know all of the things. Okay. After that, we have like memory size over here, and okay, then we have df dot is null. I'll get all the if there is a null value, I'll get it here, and dot sum. So if there is a in here, I don't have, means there is no null value. You can see in any of the column we don't have any null value, so we get it by using this code. After that, I just print my column. So you can see here I have in the form of list. I'll get a year, sex, location, cancer type, and cases, and the type is object because we have taken into uh, a list. So after that, I got the value count of a year. I'll get a 42. You can see all the data is equal. The reason maybe the data set who written or taken by a medical institute. I think so. There will be some. They have given the specific data only, so I'll get equal data here. You can see even in a 6 I have 42 women's and then we have 42 men's. After that you can see a location, then we have a value count for this. Then for above we know the data contain the 5 column in year of a 1985 and 1986. Then we have a 6 male and female as it is given in a column woman and men. Then we have a location Gomel, Mogilev and Belarus. Mera pronunciation, if my pronunciation is not, I know I'm not pronouncing right name of a cities or the location. So forgive me for that. Then we have a cancer type like skin, thyroid, lungs, pancreas, colon, and rectum, and kidney. And the cases, as I mentioned, the cases out of 100 are like it is given in a float. Okay, after that, what I have done here, a group by thing. Before moving here, I'll just show you what is group by, what is mean by group by. In pandas, group by is used for grouping the data according to categories and apply a function to the categories. It also help to aggregate the data efficiently. So if someone asks you what is group by is nothing but a grouping the data according to the category and apply the function on that category. It also help you to aggregate the data. तो अभी डेफिनेशन आपको समझ में नहीं आया होगा या कुछ समझ में नहीं आया, तो हियर इज एग्जांपल आई जस्ट zoom in. Okay, there is no function called zoom in. When I'm zooming, I'm getting okay. You can see here. I have one data set and I have the column name, team, number, position, age, height, weight, college, and salary. There is some college. It is related to a person who is having a team, number, position, age, and given the salary. So I have applied the group by thing on this data set on a team column. So whenever apply on a team, I'll get the team data. It will be divided into a group of a team. So I'll give you a simple example over here. I'll just go and just okay. Now, if just understand what is group by mean. Okay, if I have like uh, a class, then I have I'll write college name, and then I have the sports. Okay, and here I have marks. Okay, then I have some data over here, like here. In the class, I have standards. Okay, standard fifth, seven, six, seven, eight. Then I have college name or school name, you can say, or here you can just understand the the concept over here. Like school name, you can take it here. I have given some school name. Then I have the sports like cricket or other thing, and then I have some marks over here. It is in the form of int. You can see that this is in the string object, or here also object. Then you can see tick as object or int. You can just write it 5 5. So I'll just group by on the college name. So what I have get, the college name, like I have write college, college A, B, C, and then I'll get uh, if I take this data set as a DF, and then I group by on column name class, it will categorize on this number. Then I'll get all the uh, college name, then I'll get all the classes under that. In that I'll get all the sports, and then get marks. If I use here a marks as a mean value, marks dot mean, so I'll get the mean of all the marks over here. Okay, or you can just add the sum aggregation function, whatever the aggregation function you mean, median, mode, aggregation, sum or average, whatever you want you can apply over here after that. But it will group by the college. Even if I can add the multiple group by column, like here I can add the college name also and the standard. So what I'll get, a college name, then I'll get the standard, then I'll get number of standard, then I'll get marks, then I'll get the sports. All this thing will be categorized, and that's what we have done over here. Let me show you. If I go here, you can see group by the location. So I group by the location, df dot group by. I'll just apply my data frame on a group by. I'll put my location and year, and then I pass the I'll apply the case of a sum. So I'll get the number of cases happen in that year on which location. So Belarus in 1985, I have a total number of cases over there is 121.5, because it is a floating value. So I'll get it that. So you can see it is categorized by location and year. On that, I apply the cases, which gives me the sum of cases. I can use here a mean also. You can see, if I apply that, I'll get the mean of all the cases. So you understand what is group by thing. After that, what I have done, I'll use the PLT, matplotlib PLT, and I use the figure size is 9, the width is 9 and height is a 4. So you can see that. After that, I use the title as an plt.title. I have number of cases versus location, you can see here. Then I have used the font weight called bold, and the font size is 15. After that, sns dot bar plot, I given the x as a location. You can see the location I have given. Then y, I have the cases, number of cases, and I pass my data set over here. Data is equal to df. And for a u means the color, you can show it in the color. Like you can see here the colors, hue is the background color. The number of, you can see this is the number of patient size, like how many cases happen, 15 cases over that, uh, out of 100 will, I'll say. And after that, I have like cases in what year I have number of cases over there. You can see in 1985, 1996, here it is denoted by color. You can see I have rotation is equal to 0. If even if I don't use this one, it will not affect my graph. Then I have x label is equal to location, and y label is equal to number of cases, and then I have passed my font size. And then by lim, I don't know exactly why lim is what is meant by that, but I have used um, okay. After doing that, I'll move forward. Then I group by on a 6 and year. I use the two column, 6 and year. It is divided into a two. We have six like men and women. After that, we have a year, 1985, and then 1986, and we have a cases on. You can see I use the mean over here. You can do the same thing by watching this video, and we use the same bar plot over here. And I'll just pass my 6 as a on a x-axis. You can see on a x-axis we have a 6 of women and male, and after that I have like y-axis I have number of cases over here. On data, I'll pass my data frame. You can see here. So you can see women's uh, have less affected than the men affected more than the women. You can see here in the sex ratio in 1985 also, and 1990, 1986, because most of people who work there in that power plant, they are obviously affected by that explosion, and also the people who are surrounded are affected by that explosion. And so that's the reason main work men always work in, means not always, because they are higher for this type of work, like uh, that women can't do such a work, like in power plant size. Most of women are not afraid, but when people are higher, they are most probably men, and that's the reason. And I think one can't do such a thing over there. That's the reason. So after that group by on, we have taken the cancer type and year. On what year, what type of cancer have the number of cases. Over here, you can see I have used the sum, and if I run that, I'll get on kidney on Canon in 1985. I have 32.4 cases in 1986. It is increase, and it is 48.7. So you can see the increase in that graph, increase in the number. You can predict, you can show that that because of before 1985 there are in that year there are less number of patients, but in 1986 it is increased rapidly. And you can see in every type of cancer, you can see there is a rapid or increase in that patient is very high as compared to 1985. So you can show that to your client, or whatever the person you are trying to show that, because when you explain that in a graphical way, it will be very superior, and it will be like people don't have to memorize all the numbers. When they see a graphical view, they understand that uh, the point you are showing very easily. So you can see here in lungs, you can see in lungs cancer, there is there is a high number of patients. You can see in skin also and lungs also, as compared to all other are less, but they they are there only. So number of cases for such location, you can see the cancer on a x-axis type of cancer, then we have a patients on y-axis, and we use the data as a data and q as a year. Okay. And some parameter you can just go on sns seaborn side, or and you can see what are the parameter you can palette. If you go over there, you'll get what is the palette. Okay. So I'm not going to explain all those things over here. Then we are try to graph the pie plot. In the pie plot, you can understand the percentage of total cases in 90 in these 2 years, like 1985 and 1986. In 1985, there were 42% of cases of uh, are the cancer cases, and it is increased by 58%. So you can see here it is in increase by a 16% in 1986. That's the effect of that explosion over there. Okay. So here what I have done, y1 and y2, is I have stored the number of cases by using the sum. Df dot year is equal to 1985 and cases dot sum. So I'll get the number of cases happen in year 1985 and 1986. I store in y1 and y2 respectively. After that, I use the ex. These are the hyper parameter you have to pass when you trying to plot a pie chart. So z is nothing but the parameter we want to show over there. Then the label is lab. You can see the label, like here you can see the label. These are the label of 1985 and 1986. Then we have a color. We pass the parameter called color. Then after that, we have the explosion. This is the explode. Actually, explode means the gap between these two are given over there. And after that, we have the color, or we can say we want to show this into percentage. So I have to give that into percentage. So you can see here, this is in the percentage format. Okay. After that, we have rotatable label is equal to true. So whenever we rotate, our label also rotate, it's equal to true. Then we have a color. We have pass our color label distance, and label distance from our pie chart is equal to 1.2. And the pie chart, you can see the pie chart. If I decrease this 1.2 to 1.1, the gap between these two will be less. Okay, you can do some, or you can play with that hyper parameters, and you'll understand what I have done over here. Okay, so after doing that, we have going to calculate the cancer rate for the year of 1977 to 1985. Here you can see the the number the total number of cases and total number of people I have count, and I'll just apply the sum and count the. So the total number of case divided by total number of people, I'll get the total rate in the year of 1987 77 to 1985. So the data is actually we have data of 1985 only, but they are trying to show that before 1985 we have number of cases, and after that. So that's why they taken the range of 1977 to 1985. You can write it as a 1985 only here, the cancer rate in year 1985 also. So total number of cases, you can see the total number of cases, and then we have a count, total count. So the total number of case is out of 100, and we have sum it out, and then we have the count of 42 uh, number of cases we have total people. So we have divided and we get the 8.5, around 9% cancer rate over there in 1977 to 1985. After that, for year of 1986, we have only right now we have only data of 1986. We don't have the data of 1987 to 1999. So we have only taken the number of case, here again total number of cases and total number of people from the year of 1986. And we, what we have done, we have taken the total number of cases divided by total number of people, and I'll get so you can write it, you can print here the cancer rate in year 1986 only. You don't need to write 1986 to 1999, because we don't have the data of 1990 from 1987, 88 or 89. So we have only data of 1985 and 86. So you can just write it 86 here, and we have the increase in that, like for 12.4. So it is around 4% of increase in the patient of cancer over here, you can see. So so the increase in cancer rate from the period, you can see I have graphed the regulation plot, regression plot. It shows the graphical and the point. The You can see here 1986, we have around more than 70 patients over there, like peoples are affected because of that. So you can see here. After that, the current cancer rate difference between type of before and after that. So we have the cancer type, you can see skin, thyroid, lungs, pancreas. And you can see on y-axis I have the cases, and x-axis I have the years. So 90, because we have only data of 1985, you can see only dots, or only here you can see only spot on 85, and it is not in 1985 month wise, not it is year wise. So because of that, we have like 1985 we have like around 52%, 52 cases. In 1986 we have more than 70 cases on, most of them are from lung cancer. You can also see here in the here lung cancer are, you can see means वहाँ पे दिया गया है कि lung cancer are more as compared to other cancers. So cancer rate in male and female, you can show the LM plot. You can see I have provided y and x and q as a sex. So in human and men, you can see male are affected more as compared to the woman, uh, by because of explosion. You can plot it and you can show, and which year number of patients in female and male you can show also. Then we have a cancer rate in different place before and after Chernobyl. So you can see we have a three location, and I have plotted over here. You can see on Mo- Mugilev, Mugilev or whatever it is name, but it is more affected place in this location. Means from these three location, Mugilev is more affected, and after that the second affected most place is Belarus. Okay, you can show that to your client or whatever the person you are trying to explain it or represent it. Increase in cancer rate after this Chernobyl. So what we have done, we have taken the rate, like total number of cases divided by total number of people, total number of cases divided by total number of pieces. We have created rate 1 and rate 2. And after that, we what we have done, we uh, uh, minus that rate 2 minus rate 1 and divided by rate 1. So I'll get all the increase in cancer rate. You can see 38%, 40% is increase in, as I mentioned before, 40% of increase in the cancer rate in 1986, because after the explosion. Increased cancer rate in gender wise, you can see here. I have used a group by, and I'll sum it. I use the sum and count over here, and you can see the men are affected in this year. How many men's and women's are affected on these years, you can see. And you can even plot the number of, you can see 41% of male are affected and female are affected only 29. I'm not use sorry, I'm using 29. It should not affected anyone over there, but male are affected more in Chernobyl because of that explosion, you can see. And how I calculate, you can just use that sum and multiplication, and you will get all the things. Okay. So what we have done, like we have taken the number of sum divided by the total number of count divided by count, and minus on year of 85, and then we have a total number of count is 21. Then we have taken the count of year 85 divided by this, and we'll get some value over here. You can see this is the value. Then we have increased cancer rate in cancer type of Chernobyl. So now, what type of cancer are increased, you can see here. And after that, you can see the cancer rate is increased. So 46% of cancer are lung cancer, and you can see very less is skin, like uh, colon is very means the cancer colon is very, not very, because it's 0.5%. Like this is skin cancer are less as compared to other cancer, so you can see here. And is most affected because of that explosion. Lung cancer happen most of the people over there. People increase cancer rate different location, you can see different location affected. You can see here I have some calculation. You can see Belarus is more affected location in all of the three places. But after that, Gomel is second affected, second most affected place, and then Mogilev. So, what is the conclusion? Cancer rate increase after the Chernobyl explosion by 40%, around 38.8%. Increase in the rate is men are affected more than women's. Increase of the rate of thyroid patients are increased. Then we have a kidney, then we have a colon, then we have lungs. But I think this thing is not shown properly. We need to change as per the graph. You can show lung is affected more, and you can do that. Then we have a Belarus is more affected than Golem, and then we have Mogiliv. So what type, which place is more or location is more affected with what type of cancer? So we have lung cancer more than the thyroid. You can just change the uh, chronicle in this line. Okay. So we have the conclusion with us. So if you like this video, share my channel and share with your friend and subscribe my channel. And if you just like 50% of data, please like this. If you understand like what I have trying to show you here, like my video, because when you like it, YouTube will recommend other people who really want to like such a data. And please subscribe my channel, because I think only 20% of people are subscribing, so it is very less as compared to people usually should do. So thanks for watching this video, and stay tuned. I'll show you in the next video. just go over here. Just go over here. I'll just